Hello students, welcome to this lecture. And in this lecture we're going to start by talking about danger of a power rule. So let's look at the following short example, actually a couple of examples just to understand why it's dangerous to use the power rule. And you have to be careful. So if we want to find derivative of x cubed, according to the power rule, n is equal to 3. So we can take 3, we can put it down, and we can write x to the 3 minus 1. So we're going to get 3x squared, right? So this is nice and easy. But if someone asks us, what is the derivative of pi cubed? So pretty much we can apply the same idea, right? 3 goes down, then we have pi to the 3 minus 1, so 3 pi squared. But actually, this is a completely wrong solution. This is not really good. Why it's not really good? Because pi is a constant, right? Pi is some fixed number. And if you take pi and we cube it, it's going to be equal to a constant. All right? But what do we know about derivative of a constant? We know the derivative of a constant is 0. So this implies that if we take pi cubed and we take derivative, we should get 0. So be careful. Here it should be variable or some expression with the variable cubed. If it's some constant cubed, then the answer should be 0 for the derivative. So that's why this is a really dangerous rule to use. All right, so we discussed it a little bit. And the next idea that we need is the product rule. So theorem about product rule. So product rule. Let's try to see what would be the product rule. If f of x and g of x are differentiable functions, then if we create a new function h of x, which is the product of f and g, then this function will also be differentiable. It's also differentiable. But not only that, but we can also write its derivative down. And derivative of h is derivative of f times g. And it's a little bit more complicated than before. So it's derivative of f times g minus f times the derivative of g. All right, and this is called product rule. And our goal is to prove this product rule. So let's try to go through the proof. And the only thing we have is just a definition. So we take f times g and we take derivative by using the definition. So it's going to be limit delta x goes to 0. We have to calculate this function at x plus delta x. So it's going to be f of x plus delta x times g of x plus delta x minus f of x times g of x divided by delta x. So now it's not really clear how to continue. We don't know much about f, we don't know much about g, we can't really do anything, so we're going to use magic. So what I mean by magic, it's a mathematical magic, so we're going to use mathematical trick. So the trick goes in a really strange way, but let's try to see what's going on. So we have first expression, but then we're going to do the following. We're going to, out of nowhere, subtract f of x times g of x plus delta x. So I'm just out of nowhere, I subtract this expression. But if I subtract this expression, I also have to add the same expression because otherwise my numerator will be ruined. So I subtract and add the same expression. So if you add them together, you're going to get 0. So it doesn't really change my original numerator. So at the end, I still have f of x times g of x. So again, it's a mathematical trick. It comes out of nowhere, but you will see how it works. So now we have to combine some expressions together. So I'm going to combine the first expression with the second expression. And then because I have a plus over here, I can split it into two different fractions, which we did before. So it's not really new to us. So we have a limit, again, first one and second one together. So the first one and second one together, and then we're going to split it up into two different fractions. So I put a plus and I combine these two together in the second fraction with delta x on the bottom. We have f of x, g of x plus delta x minus f of x, g of x. All right. But now we can use the rules for the limits. If we have a plus inside of the limit, we can split it into the two different limits. So we're going to get limit of the first expression. But while I'm doing this, I can also look carefully into this expression over here and notice that the g of x plus delta x is a common factor. So I'm going to also factor it out. So I factor it out. I'm left with this expression, which is f of x plus delta x minus f of x divided by delta x plus limit delta x goes to 0. What's going on in the second expression? In the second expression, you can see that f of x is a common factor. So we'll take it, we'll put it outside, and inside we'll have g of x plus delta x minus g of x, all divided by delta x. All divided by delta x. All right, now let's think about this function over here. Here I have a product, so I can use the rules for the product. So I'll have limit delta x goes to 0 of g of x plus delta x times the limit when delta x goes to 0. Delta x goes to 0. And here we'll have f of x plus delta x minus f of x divided by delta x plus, and here we have limit when delta x goes to 0, so f of x is here, times the limit when delta x goes to 0 of g of x plus delta x minus g of x over delta x. So let's try to analyze. First of all, what is this thing? This thing is actually the definition of the derivative of f. Look, delta x goes to 0. This is f of x plus delta x minus f of x over delta x. So this will be f prime of x. And here we can use direct substitution, so we can plug in delta x equals 0. So we'll get g of x. And over here we have limit of f of x, but f of x doesn't have delta x in it. So we use direct substitution, we're going to get f of x. But this part is exactly the definition of the derivative of g. And we're done with this proof, so check mark. We've done it. So again, complicated rule, yes, but it is what it is. You can't really change it. So let's do a few examples just to see how this rule works. All right, so let f of x be equal to square root of x over x. the assignment wants us to find f prime of x. So let's try to do that. We have derivative of square root of x over x, but we can write it as square root of x times 1 over x as the product of two functions. And we can use the product rule. So the product rule says take square root of x, take derivative, multiply by 1 over x plus square root of x times the derivative of 1 over x. So we use the product rule. And now we calculate derivative of the square root of x, which is 1 over 2 square root of x times 1 over x plus square root of x times the derivative of 1 over x, which is negative 1 over x squared from our library. And that's pretty much what we have for this expression. So we'll stop over here. All right, so in the next example, we're asked to find derivative of the following function. Calculate the derivative of 2x squared plus 5x minus 7 times x to the 5 minus 1 derivative. So we have a couple of different ways to do it. First way is to FOIL it out, calculate it. It will take us some time, and then take derivative of a polynomial, which shouldn't be hard. And another way is direct approach by using the product rule. So it will tell you, take the first function, find derivative of it, multiply by the second function, add the first function multiplied by x to the 5 minus 1 with the derivative sign. So let's do one at a time. So it's going to be derivative of this expression over here because of the plus and minus. So what would it be? It would be 2 is a constant, then we need to find derivative of x squared. And derivative of x squared is 2x. Then we put plus, 5 is a constant, derivative of x is 1, and derivative of a constant is 0. So that's what we get for this function. And then we have 2x squared, 5x minus 7, and we take derivative of x to the 5. So we're going to use the power rule. Power rule says take 5, put it down, subtract 1 from 5, so we're going to get x to the 4. And then we take derivative of 1, which is 0. So finally, our answer is 4x plus 5 times x to the 5 minus 1 plus 2x squared plus 5x minus 7 times 5x to the 4. And that's our derivative over here. All right, so since we learned the product rule, it's time to learn the quotient rule. But before we do the quotient rule, we need to do an extra small rule. And usually small rules that do not deserve to be called theorems are called lemmas. So lemma means like a small theorem, which is not really worth of calling it a theorem. So it tells you the following, that if you have a function that looks like 1 divided by some other function, and g of x is not equal to 0, and also g of x is differentiable. So if we have h of x, which is 1 over g of x, and g of x is not equal to 0, and also g of x is differentiable, then what is the conclusion? Then h of x is differentiable, and at the same time we can say that the derivative of h is -1 over g of x. Maybe let me fix it a little bit, write it in a better form. Here we would write g prime of x. So negative g prime of x over g of x quantity squared. So let's try to show that this is true. What would be the proof for this result? The proof for this result is h prime of x is equal to the limit when delta x goes to 0, h of x plus delta x minus h of x divided by delta x. So what we need to do, we need to take x plus delta x and put it into our h function. So put it over here. So let's try to do that. So we say limit delta x goes to 0. We have 1 over g of x plus delta x. So what we did, we took x plus delta x, we put it over here. Then we have a minus, and we have g of x in the denominator, and in the big denominator we have delta x. So since we have a complicated fractions, what do we mean by complicated fractions? We mean fractions inside of the fractions. We need to create a common denominator to simplify. And why I'm not using direct substitution, you might ask? Because if I use direct substitution, then I will get 0 in denominator, so it wouldn't work. All right, so let's do this. Delta x goes to 0, common denominator for the numerator. So we're just going to multiply g of x plus delta x by g of x. So this fraction over here is missing g of x. So it's going to be 1 times g of x. 1 times g of x. Then this minus. Then this fraction is missing g of x plus delta x. So we're going to put it over here. 1 times g of x plus delta x. And the whole fraction is divided by delta x, but I'm going to think about it as delta x over 1, which we've done already a couple of times this semester. Let's do this out, simplification part. So we say equal, limit, delta x still goes to 0. What's going on in here? We have g of x minus g of x plus delta x. And in the denominator, we have g of x plus delta x. Oh, technical issues. All right, so one more time. G of x minus g of x plus delta x divided by g of x plus delta x times g of x times the reciprocal of delta x. So it's 1 over delta x. 1 over delta x. All right. So everything looks good. So let's try to rearrange the terms. So we're going to rearrange the terms. So we'll write limit delta x goes to 0. So what I'm going to do, I'm going to take these two terms over here. And move them way at the end over here. So I'll write 1 over g of x plus delta x times g of x. So I move these two terms at the end. Then I still have my numerator, which is g of x minus g of x plus delta x, and it's divided by delta x from here. So everything looks great, but actually I can write it as a separate fraction and write it as a product. All right, so we can use the rule for the product and write it as two different limits. I'll write this limit at the end, so I'll have limit delta x goes to 0, 1 over g of x plus delta x times g of x. And then this limit, what I'm going to do, I'm going to look at it very carefully, and I notice that if I would switch around these two terms, it would be exactly the definition of the derivative of g. Look, this is g of x plus delta x, and this is g of x, but they're in a wrong order. So what do we need to do in order to switch the order? We can factor minus 1. So what I'm going to do, I'm going to write it as limit delta x goes to 0. I'm going to factor minus out, and in parentheses, I'm going to write g of x plus delta x minus g of x divided by delta x. And minus here is just a constant. So basically what I can do, I can take this minus and I put this minus 1 up front. All right. So what I did, I factored out minus 1, I switched the order, and now this is exactly g prime. So we have minus 1 times g prime of x times, and now we calculate this limit at the end. And we're going to use direct substitution. So this term over here is just going to be 0 if we plug in 0, and we're going to get g of x times g of x, because in this term there is no delta x. So if we put everything together, in the numerator we have negative g prime, and we have g squared of x on the bottom. So we prove this rule. All right, so since we proved this rule, can we apply this rule to some examples? So first example we're going to do is our famous 1 over x. So let's try to apply this to this function that we actually know the answer for, but we'll do it in a different way. So according to this rule, we have to put minus, we have to take function from the bottom, and we have to put derivative sign in it, and on the bottom we have to put the function squared. What do we know about derivative of x is 1, so we have negative 1 over x squared, and that's actually what we knew from before. So that was just to practice. Now some real example. If we have x squared minus 5 in the denominator and we take derivative, this is our g of x, right? This is our g of x. The rule says take minus, take the function g, take derivative, and on the bottom put x squared minus 5 squared. So let's calculate derivative of this function. We know derivative of x squared is 2x, derivative of 5 is 0. We have to put minus from here, and on the bottom we have x squared minus 5 squared. Finally, we have negative 2x over x squared minus 5 squared. So this is our answer. And the last rule for this lecture, with a few examples, would be the quotient rule. So theorem, right? It's a rule, so it's a theorem. Theorem is called quotient rule. Quotient rule is not easy to prove, but and not easy to even remember. So let's try to look at it. Suppose we have f of x and g of x. So f of x and g of x. Let me be a bit more accurate. And g of x are differentiable and g of x is not equal to 0. Then if we create h of x by taking f of x and dividing by g of x, if we create h by taking the quotient, is differentiable, and the derivative is a little bit more complicated than the product rule, but let's try to do that. We have f prime of x times g of x minus f of x, g prime of x, and on the bottom we have g of x quantity squared. So that's the quotient rule. Minus is really important, therefore the order is kind of important here. Some people write it as g of x f prime of x minus f of x g prime of x divided by g of x quantity squared. But again, that's my preferred way. As long as you remember it, it's fine with me which way you remember. So let's try to prove this idea. Proof. So we need to find derivative of h. We need to find the derivative of h. And we're going to find the derivative of f of x over g of x. But fortunately, since we proved the previous lemma, it will be relatively easy. What we're going to do, we're going to think of it as f of x times 1 over g of x derivative. And we're going to use the product rule. So it's derivative of the first function times the second function plus first function times the derivative of the second function. So we wrote it up. And then we just need to calculate the derivative over here. So we're going to get f prime of x times 1 over g of x plus f of x times negative g prime of x divided by g of x quantity squared. Okay, so basically, if we simplify it, we have f prime of x from here times 1 divided by g of x. Then over here we have minus, so it's going to be minus f of x times g prime of x divided by g of x quantity squared. So if we would like to create a common denominator, this fraction is all set, but this fraction has to be multiplied by g of x. So we write g of x and we write g of x. So on the bottom we'll have g of x squared. So finally we have f prime of x, g of x minus f of x, g prime of x, and on the bottom we have g squared of x, and that's exactly what we wanted to show. So again, the proof was easy because we proved this complicated lemma before. So let's finish the lecture with a couple of examples just to practice, and you will practice in the homework a lot. And that's the idea of the calculus course. You get something in class and you go back home and you practice with it. So 5x to the 4 minus x squared, maybe let x cubed plus 7, and the assignment says find f prime of x. So if you want to calculate derivative of this function, we have to calculate derivative of this fraction. So let's do this out. We have, according to the rule, we have 5x to the 4 minus x squared derivative times x cubed plus 7 minus 5x to the 4 minus x squared times the derivative of x cubed plus 7 divided by x cubed plus 7 quantity squared. So let's try to do that one at a time. So 5 is a constant. Derivative of x to the 4 is 4x cubed. Y 4 goes down, we decrease the power by 1, we get x cubed. Derivative of x squared, we know it's 2x. We have x cubed plus 7, mistake. So we have a minus, we have 5x to the 4 minus x squared, and derivative of x cubed. 3 goes down, we decrease the power by 1, we get x squared, and we add 0 at the end. And on the bottom we have x cubed plus 7 squared. So that's pretty good enough. Maybe no real need to distribute and simplify. So we're gonna get 20x cubed minus 2x times x cubed plus 7 minus 5x to the 4 minus x squared times 3x squared divided by x cubed plus 7 quantity squared. And we will do one more example to end the lecture. In this example, we're gonna need to use the quotient rule again. Example. So let h of x be equal to square root of x over x squared minus 3x plus 2. Find h prime of x. So what would be the solution in this case? In this case, we have to find derivative of square root of x over x squared minus 3x plus 2, and we're going to use a quotient rule. So it's derivative of square root of x times x squared minus 3x plus 2 minus square root of x times the derivative of x squared minus 3x plus 2. And on the bottom we have the expression squared. So x squared minus 3x plus 2 quantity squared. So we say equal. And we start to calculate it. Derivative of square root of x, we know it's 1 over 2 square root of x times x squared minus 3x plus 2 minus square root of x times x squared minus 3x plus 2 divided by x squared minus 3x plus 2 quantity squared. Oh, didn't do it right. Sorry. Forgot to take derivative here. Just rewrote it. Everyone can make mistakes. Me too. You have to watch me, and if you see something wrong in my lecture, definitely email me and tell me. Derivative of x squared is 2x. Then negative 3 is a constant. Derivative of x is 1. And derivative of 2 at the end will be 0. So I'm not going to write it because I usually don't write zeros. And probably I'm not going to write 1 either. So this is my answer. Unless we need to do something else, I wouldn't simplify it. But if we have some more assignments, like we need to do something else, we might have to simplify it. But for the all purposes for our class, it's good enough. So probably a good time to stop. I'll see you in the next lecture where we're going to come back to the power rule.